This past February, Congress passed the FAA Modernization Reform Act of 2012. This act requires the development of a comprehensive plan to safely integrate unmanned aircraft systems, or UAS, into the National Airspace System, or NAS. What does this mean to the airline pilot? Will it affect my operations? How will I avoid hitting these aircraft? How will they avoid hitting me? Will they be a new threat to safety or just another aircraft in the system? Get that going. There we go. Currently, U.S. air operations are either restricted to segregated airspace or accommodated by procedure to separate them from other aircraft in the NAS. At present, there are no FAA standards for certification of unmanned aircraft, their pilots, or the operators who employ them. ALPA is involved with rulemaking activities that are working towards such standards. Operations are currently approved by the FAA under a certificate of authorization or through issuance of an experimental certificate. When we speak of UAS, what is the scope of unmanned aircraft? I mean, how bad can a small model aircraft affect me? Well, UAS aircraft can range in size from something smaller than an RC airplane to an aircraft weighing many thousands of pounds. The Global Hawk weighs in at about 25,000 pounds. The control stations can range from a standard handheld RC controller to a ground station contained in a large trailer or office, and incorporating a pilot station and perhaps other supporting positions and personnel. These unmanned aircraft can be operated within line of sight or beyond the horizon through satellite or terrestrial communications. Who will fly these unmanned aircraft? It's ALPA's position that persons controlling the unmanned aircraft be pilots and not operators. Our view is that to be granted equal access to the NAS, the pilot in command must be trained and licensed to do so. It's important that all pilots share a common understanding and background to fully appreciate the safety implications of their operation on other users of the NAS. In addition, the licensing of UAS pilots and airworthiness standards for the unmanned aircraft they command are not only for the well-being of passengers and crew already flying in the NAS, but also for the general public who reside under the NAS and expect a high level of safety in flight operations that are being conducted over their businesses and homes. UAS pilot and command responsibilities raise new questions such as the accountability when the pilot and the vehicle are located in different countries, or in the event of lost link if the aircraft is operated on a pre-programmed path. In addition to these questions, industry and the regulator are working to overcome unique technical difficulties as well. In manned aviation, it's expected that pilots see and avoid traffic and other hazards. However, when aircraft do not have a set of eyes on board, how is this to be achieved? A new concept is introduced called sense and avoid and attempts to close this gap. It's not simply a matter of equipping UAS with transponders and existing traffic collision avoidance systems. UAS must be compatible with TCAS-equipped aircraft, but also remain safely separated from all air traffic. ADS-B may eventually offer a possible solution to this issue. But meanwhile, safe separation and collision avoidance remain a significant challenge. This points to another challenge the industry is facing, that of lost link and spoofing. There have been a number of UAS accidents and incidents due to the interruption of command and communications from the ground station to the UA. Losing this ability to control the UA while it is intermixed with commercial and private aircraft operations needs to be avoided through improved reliability and design, as well as onboard programming that results in safe, compatible, and predictable performance during periods of abnormal operation. Security measures must be included to protect the UA from electronic hijacking, deliberate corruption of navigation signals, or unauthorized access to the control station. Although the Aircraft Design and Operations Group is focused on the technical aspects of introducing UAS into the NAS, there is the other question on many pilots' minds. Is my job as an airline pilot in jeopardy? Can the technology that comes out of UAS be used to replace the onboard pilot for cargo and passenger operations? The technical answer is not yet. The technology is still being developed. Can technology alone allow for the complete removal of one or more pilots? Not likely for human factors, economic, and technical reasons. However, some aircraft manufacturers have entertained the idea of a single pilot airliner. In the meantime, UAS is coming to airspace near you. ALPA is committed to ensuring that the integration of UAS into the NAS and the sharing of our airspace is done as safely as possible. To help better understand where UAS is in these challenges and what we might expect going forward, the ADO group assembled this panel. With me today are Mr. Richard Prosek, FAA AFS 80, UAS Integration Office, Mr. Paul McDuffie, Associate Vice President of Government Relations and Strategy for Insitu, Colonel Carl King, DoD RPA Liaison to the FAA, and Captain Ellis Chernoff, ALPA's representative to all things UAS. You'll find their bios in your forum program. Each of these gentlemen will present some remarks, and I'll open up the floor for questions. So, I'd like to start with Mr. Prosek to walk us through the pertinent parts of the Reauthorization Act, including UAS and what it means for the UAS integration. Mr. Prosek.
Thanks, Bill. It indeed is a pleasure to be here this afternoon to talk to you about, I'm trying to figure out if we can get the slides up. Hey. Step back just a little bit. It's really a pleasure to be here this afternoon to speak to you about this topic of unmanned aircraft systems. And this is a topic that I actually have had the pleasure of working very closely with all of my fellow panel members here over the last few years. And we could probably go on for 10 or more hours, and it'll be very difficult, but I'll try to get a couple of quick remarks in here and look forward to your questions afterwards. What I'd like to speak to in the few minutes that I've got allotted here is just kind of a macro view of what the FAA has with respect to unmanned aircraft systems. As Bill indicated, I'll speak real briefly about the Reauthorization Act, and then finally wrap up with a few of the things that we have underway to comply with the provisions of that act. I know many of you are international and are aware of how things are in other countries. We do have a very good luxury here in the United States of having housed within a single agency our air navigation service provider in the form of our air traffic organization and the regulator in the form of our aviation safety organization. But just having them housed within the same agency we found was just not enough, because the integration, safe integration of unmanned aircraft systems really is cross-cutting, and we needed a very close alliance of these entities. So recently the agency has stood up, and we are in the process of a reorganization effort to put together the Unmanned Aircraft Systems Integration Office, and we are now under a single focused executive as the point person for unmanned aircraft, Mr. Jim Williams. Mr. Williams was not able to be here today, but he sends along his best and his support and this message of safety for you. The vision from our office is kind of a trilateral entity with basically focused on the safe, efficient, and timely integration of unmanned aircraft systems into our national airspace system. As you can imagine, there's just a little bit of a yin and a yang, a little bit of conflict in some of these goals. We could perhaps find a way, if someone wanted to fly a Global Hawk from Kennedy Airport and fly to O'Hare and land on 22 left, we could find a way to do that safely, but it would come at the expense of the efficiency of our national airspace system. So our big focus here is to try to concentrate or find that sweet spot balance of these three entities, but the overarching trump card is that safety one, which is basically our mantra at the FAA, is to ensure that we protect the safety of the NAS as we integrate new technology, as we have done over many different iterations of technologies over the years. Some of the macro views here. Why do we use, and as opposed to Bill's comment of aerial, we use the term UAS with unmanned aircraft system. And we felt strongly enough about this that 5 years ago, in 2007, we published an item in the Federal Register that basically had two main stipulations in there, that an unmanned aircraft system, one of the components was indeed an aircraft, and that as an aircraft, it was flown with utilizing a pilot in command. And so those are two tenets that we have stated 5 years ago, and that is still our mantra, and basically we do all of our work with that in mind. Turning to our legislative initiatives, on the 30th of December, the National Defense Authorization Act was passed, primarily for the Department of Defense, but in there was a mandate for the Secretary of Transportation to stand up 6 test sites for UAS. I believe speculation probably is that some on the Hill thought that perhaps after 23 extensions of our reauthorization bill that perhaps the FAA was not going to ever get a reauthorization bill. But lo and behold, about 6 weeks later, on Valentine's Day, President Obama signed into law the FAA Modernization and Reform Act of 2012, which also included provisions for these 6 UAS test sites and nearly verbatim language from the NDAA language. Along with that, the language spanned about 16 pages of legislation, and in that language there were covered 6 different parts. Highlighted here, probably the big one, that test sites back in there, and then the comprehensive plan that Bill spoke about earlier. Here's a few of our steps of actions that we're taking on that road to the integration of unmanned aircraft systems into the NAS in 2015. One of the things I will point out that gets often misspoken in the press is that the language does not say full integration of UAS into the NAS by that date. It says safe integration. And it sounds like a small sticking point, but it actually is a pretty germane and significant factor. Some of the items that we are using right now in our approach to try to organize for this effort involves a few products, and these products are all being developed in concert with one another and folding themselves into a whole. And ALPA is represented in these products. The first 2 products that I've listed up here is the FAA's UAS NAS Integration Roadmap, which is being developed by Mr. Williams' office, and then the FAA's Concept of Operations, which is being produced by the FAA's NextGen office. However, we do have a unmanned aircraft system Aviation Rulemaking Committee that we stood up last June. ALPA has a very vocal and active participation. In fact, our ALPA member chairs one of the work groups on that Aviation Rulemaking Committee, and we've received recommendations on both of these products from the ARC that we are now in the process of folding into the final products, which will be delivered by the end of September. And these 2 products will be 2 of the 4 elements that go into the comprehensive plan that Bill spoke of. And the responsibility for that plan has been placed on the Joint Planning and Development Office, which essentially is comprised of all of the NextGen partners, the FAA, not just the FAA, but DOD, NASA, Department of Homeland Security, Department of Commerce, and others. So ALPA has a voice and has been very key in helping us put these products together, and we're very happy to have that support and those recommendations. Finally, this is just a real quick synopsis of some of the measures that we're taking to make this UAS NAS integration a reality. And probably the 2 items I'd like to stress on there is that we're doing this in an organized and structured fashion using these comprehensive plan and the supporting documents that are going into that plan. But probably the most important thing is the second bullet there, is the integration of safety into all of these activities. We take it very seriously, the safety, not only of the safety and the efficiency of the National Airspace System, but also the protection of the persons and property on the ground underneath the NAS. So I'd just like to leave you with that basic thought that we are very energized in trying to enable the integration of this new technology, but we certainly want to make sure that safety is integrated into the process at each step of the way. I certainly thank you for your attention. I want to call to your mind once just to reinforce that it is our intent to integrate UAS into our national airspace system in a manner that is safe, efficient, and timely, and I look forward to your questions. Thank you.
Thanks, Rick. With the complexities involved with UAS, certainly looks like it's a pretty big job. And as always, the first step is to have a very good plan to move forward, well thought out plan. Generally, new technology is not developed for new technology's sake. There's usually need and a market identified. So I asked Mr. McDuffie to come up and present his views regarding the near and long-term civil market for UAS and some hurdles that must be overcome.
Well, thank you, Captain Groh, and on behalf of our family at Insitu and our parent company, Boeing, I want to thank ALPA for the opportunity to have a dialogue with you a little bit about the kinds of things that we face as a UAS system manufacturer. If you don't know, our parent company, Boeing, and the company I work for, Insitu, we are manufacturers of very robust UAS systems. The products that the Insitu company produce have been supporting our DoD customers and the warfighter and theater now for almost 10 years with over 700,000 hours of deployed experience in a number of places around the world. But we are at a point now where things are changing. We are looking very seriously at the emergence of a commercial market, a civil market, and as such, need to review exactly how we're going to enter that market and how we're going to shape ourselves for the future. It's pretty clear to us that a market does exist. As the DoD experience has proven, UAS have tremendous capabilities, many of which are now being realized by the civilian marketplaces outside the DoD market. We are in a situation, though, where the technology appears to have outpaced the regulatory environment. And as a result of that, there are a number of misconceptions about what UAS are and what UAS are not. So it has been the tasking of the industry of late to begin the process of doing a realistic shaping of that market so that the expectations that the public have about what our capabilities are in fact realistic. So I wanted to share with you some of those concerns that we have and hopefully open up a dialogue about it going forward. One of the things that we face every day is the misconception that UAS are an inexpensive alternative to a manned aircraft type of deployment. At this point in time, nothing could be further from the truth. Until routine access to airspace and routine and regular use of UAS occur, we are looking at a situation where the economics may not be what everyone anticipates. We are still competing with a manned aircraft environment, a manned aircraft world. In spite of our name, unmanned aircraft systems are not truly unmanned. There is a sizable human footprint associated with the operation of vehicles of all different sizes, shapes, and capabilities. We obviously have pilots, we have ground support individuals, maintainers, trainers, payload operators, and those who actually mine the data that these systems collect. All of that adds to cost of the operation of the vehicles, which in most cases today does not make us overly competitive with a manned environment. We hope to change that. We expect to change that. As the certification requirements become better defined, and you heard, Rick mentioned it earlier that FAA is working very aggressively to achieve that goal. Once those requirements are defined and coalesce, it will be easier for us in the industry to do better planning in terms of our investment strategies on developing new technologies and refining existing technology. All of that will ultimately reduce cost of operation, and hopefully we'll be able to be a little more competitive than we are today. We are working that issue for certain. One of the other areas that we, and of course this is not news to anyone in this room, I'm sure, if you watch TV or read the newspaper, you know we are regularly in the news with a number of public perception issues relative to the potential of an increased use of unmanned systems, primarily as a result of the FAA Modernization Reform Act that Rick mentioned. No one in this industry expects that we're going to wake up September 1st, 2015 and find the skies darkened with unmanned aircraft systems. That's just not reality. What the Reform Act will do in 2015 is give us a baseline, something to build from, a roadmap, so to speak, that we can make those proper investments and move the technology forward so that at some point in time, the use of unmanned systems will become much more commonplace. Along with that, from an obstacle perspective, one of the major concerns we have, and it's a legitimate concern, is the public perception of what UAS will do relative to privacy. There are some, both inside and outside the industry, that believe that privacy laws have been overshadowed by technology, that a review is needed so that there can be a better accommodation for the capabilities of technology, even beyond unmanned systems. As an industry, we understand that, we appreciate that, and we will work collectively with the community to make sure that unmanned systems, when properly applied, they are done so responsibly and in accordance with all law. To that end, the industry has gathered together through the Association of Unmanned Vehicles Systems International, or AUVSI, and published what we're calling a code of conduct. This is an interim checklist of sorts that provides guidance to the industry and end users of UAS in terms of how they will conduct themselves. And it is built on basically three principles: safety being number one, professionalism being number two, and respect being number three. Safety obviously is the tantamount and most paramount concern. We want to make sure that we operate with the stakeholders and others in the national airspace as safely as possible, so everything we do is centered around that. From a professionalism standpoint, obviously, we recognize the fact that we are operating aircraft. They're going to be operated by trained pilots, individuals who understand how aviation works and how they can effectively integrate into the national airspace environment. And of course, respect. We do respect the privacy concerns and the lawful use of these systems going forward. This is not a U.S. domestic problem alone. This is a global issue. There are probably over 1,000 manufacturers of UAS systems globally right now. We're looking at an industry that is potentially in the billions of dollars annually when we have full integration of these systems on a world scale. But it's going to take some time. Most of these systems have been born through the efforts of the Department of Defense. Specifically here in the U.S., most UAS products are controlled by significant export control. So that is actually limiting some of the opportunity we have from a global perspective. All being worked on. We expect changes in that going forward as these things become operated in much more commonplace. So how are we going to get there? This is going to be an incremental process. We use the term crawl, walk, run quite frequently in a lot of our work that we do with the FAA through the rulemaking efforts. This is going to be an evolutionary process, not a revolutionary process. We're going to start operating systems where it makes sense to operate them. We're not going to push the envelope beyond our capabilities. We're going to understand and appreciate exactly where the technology is and apply it where it's appropriate. We're going to have to maintain an open dialogue. These kinds of sessions are extremely critical to us. We have to get the message out. We have to get the perception not only of the rest of us in this industry, but of the public, those who are going to ultimately benefit from the use of unmanned systems, to better understand what our capabilities are. And the only way that's going to happen is through an open and aggressive dialogue. UAS have to be actively involved in the future. The next gen development is very, very critical to to the future for us. Some of us in the industry believe that solving many of the UAS problems ultimately presents a tremendous foundation for the overall development of next gen. If you solve all the issues relative to sense and avoid and automation and autonomy, all these are very, very important elements in the entire next gen discussion. So we believe UAS does possess a very critical piece to the overall next-gen package as it goes forward. So we will stay actively involved in that, along with you, of course. And then, of course, sharing data and experience. As I said, primarily the use for UAS has been through our DoD friends and partners. They have a wealth of information which they are willing now to share. The industry, as it begins to evolve and we start to integrate these systems into the airspace, we have to have a sharing of the data openly, not only with ourselves but with other stakeholders. It's clear UAS are here to stay. It's a technology that has tremendous value. It's something that has tremendous benefit to the human spirit, and we expect that over the next few years, again, once we get through all the major hurdles, we're looking at something that is going to really contribute to the betterment of mankind. So again, I want to thank you for the opportunity to be here today, and look forward to answering your questions. Thank you.
Thank you, Paul. It's nice to hear a discussion about a stepwise approach to the integration of, well, any system. You certainly don't want to overstep the bounds of the technology and end up having to backpedal with safety issues. So thanks for that. Certainly the DoD does a high percentage of UAS or RPA operations, remotely piloted aircraft, as well as manned operations. So now we'll hear from Colonel King, who will present his views on UAS operations and how they may differ from manned aircraft operations. Colonel King?
Bill, thanks. I may have spoken with some of you at lunch not long ago. We talked about kind of how we train to operate the systems. Today I want to share with you a little bit beyond the training as to what it actually feels like or looks like, or how they work, basically. So it's kind of our integration programs and operational view. Briefly, I want to share with you what we're flying. If you look at the far side of the screen under the Group 1 side, that's the vast majority of the DoD systems. We have a lot of small aircraft, under 55 pounds, some under 20, and that's the vast majority of the systems that we're operating. As they get larger, obviously they get more expensive and we get less of them. The systems on the Group 4 and 5 side, those are the ones that you see a lot in the news about. Those are the ones that are doing the high publicity work overseas. And that's kind of where I want to focus what I'm going to talk to you about today, how to operate. That's been my background and my experience. Those are the systems as well that are going to operate or potentially can operate in the vast majority of the airspace that you all operate. I'm not going to suggest that we share it. But those are the systems that we train our operators to fly basically in all classes of airspace as we get there. The small side, again, the Group 1s and 2s, they have a very limited training program, but by limited I don't mean inadequate. It's just a little bit shorter duration. They're very focused on essentially a VFR type operation. The airspace that they fly is very constrained, 1 to 2 to 3 miles possibly around the area. So while they get some airspace and some typical stuff, mostly it's focused on how to recover the aircraft, all the emergency procedures, all of those kind of things that you focus on. But they do get some typical airspace training, which you would get basically in a private pilot or in a small aircraft. The larger systems, quite frankly, they go through essentially the same program as most of the Air Force UPT graduates would go through. They essentially they get a 40-hour program within a manned aircraft. They go out and they do solo. Then they come back and they get essentially another 200 hours or so, all within a simulator, but they go through the same curriculum that our brand new pilots go through as they go through Air Force undergraduate pilot training. So essentially a T-37, T-6 kind of program before they go off and do that. And so they graduate with essentially an instrument rating, as I would when I went through manned flight school. They graduate with basically all the same training and experience to do that from the unmanned side. Then they go off and they focus on their systems. This is what I want to talk to you about today. This is kind of what it looks like, and that is running. Yes. This is an MQ-9. This is what ground ops look like. The marshaller just stepped away. You can see him going off the back. The aircraft taxis out. If I were to take any one of you all, sit them down behind the seat, put your feet on the rudder pedals, put your hand on the throttle, you'd be taxiing just like you've taxied every other airplane basically in your entire career. We use the ball to look around as we go. We look inside our turns. We look forward. We do have people outside that are helping us monitor if necessary, such as the crew chiefs there. When we come back, they'll put the chocks in. It operates almost identically to a manned aircraft platform in that sense. Inside, we're going through all of our pre-cockpit checks. We're doing all the standard stuff that you're familiar with. We have all the same speeds, go, no go, told, everything as you go through, and then the airplane gets airborne. Beyond that, we go through essentially all the same sets of checklists that everyone else would run through, other than just being a little bit detached from the aircraft. This is what the inside looks like. You saw a picture of it earlier. Pilots on the left, our sensor operators are on the right. They're maintaining the camera, so as the pilot needs to see something, the sensor operator is going to move it. I'll show you a picture of the taxi map to give us what our outside references look like. But you can see where the pilot's looking through the nose camera image. That's where he was seeing the crew chief, as well as all this stuff. The lights show up, or the lines in the taxiway show up just as well at night as they do in the daytime. And in fact, sometimes better on the IR camera. You can see the runway striping. That's what the pilot's looking at. Essentially, we'll pull up a view of the airfield, the taxi map. It's got all the taxis laid out there. The plane moves around the taxi space so we can see where we are. We can take directions, taxiway Alpha, Bravo, Charlie, the same as everything else. You see there the marshaller picture, and the pilot's getting ready to go. Once we get airborne, so this is kind of what our pattern looks like. We change the views. We now get a smaller view or a bigger view of the local area that we're flying in. The green line that you see would be the route of flight, but if I put the autopilot and turn the autopilot on, the airplane would go fly down the green line. I can move that wherever I want in flight as necessary, be a lat long or whatever, to design the entire route of flight. The red line up there, if the airplane were to go lost link, it gives me a constant update as to where it's going to go. If in fact it went lost link, and then once it did go lost link, I would be able to transmit that data to somebody else. It's on its way to a pre-planned point that we all are aware of at an altitude, and then press on from there. If I'm just flying around the pattern doing touch and goes, we'll pull up an overlay of the pattern map, and you can see that there. We'll fly the black line. We can still see ground references through the camera, but primarily we're looking up at the screen. Oop, I missed one. Oh well, there was one more. We can do an instrument approach. We'll basically pull up this same map. It expands it out a little bit so we get a longer time on final. We'll bring up what looks like an ILS. It's basically a not wind corrected ILS. And then within the map, we have all of our altitudes planned up there. So if you're looking at approach plate, we basically replicated the approach plate up on top of the screen for us. So as the pilot's looking at the ground track, the numbers are right there for a single spot to look in the checklist. And then obviously we're looking outside for all the standard stuff. Within the ground control station, as we're flying and doing our operational things, that's one of the benefits that I've found to flying UAs. When I would go fly a mission in Kosovo or over Afghanistan in manned aircraft, all the information that I had for that entire flight was given to me about 4 hours before I ever walked out to my airplane, and that was all I had for the day. Once we get going, we have it all instantly. You see all the blue screens are essentially connected to either internet, secure high-side internet if we need it. We can chat back and forth. They've got it sorted out overseas. We can chat back and forth between controlling agencies and RAPCON facilities, as well as some of the folks on the ground, to include some aircraft actually have that capability that we can chat back and forth with real time. We have a radio. It runs through the aircraft just like everything else. So as I get ATC instructions, I acknowledge them, and then we can move the airplane. This applies to basically all of those Group 4 and 5 systems. The nose camera essentially during the mission would go down, so I'm almost always looking at the bottom of my airplane. But it provides me a HUD picture all the time, so I have altitude, airspeed, and attitude for the aircraft. The nice part about the blue screens is if there's a NOTAM that comes out or a new warning or a weather change or anything else, we always have that available to us instantly. It doesn't have to necessarily get fed, and we can get more information than I can typically get over a radio about where that is, to exactly pulling up the radar, instantaneous radar weather shot to avoid traffic and everything else. You saw the one slide that said deconfliction tool. Obviously, sense and avoid is a big issue that we have within the aircraft. What we've been able to do with the systems that are connected is depict those on our own screens. So if you look in that center screen, it's a big blow up of the world that we're flying in, and that'll scale in and out. This is just a small piece of that. But within all of our systems that we have together, we've connected the data feeds, and then we can display each of them. In fact, sitting in Creech Air Force Base flying an aircraft, if the aircraft's in Afghanistan and I need to know for some strange reason what was going on in another part of the world, I can scale all out, go over and scale back in and still see those, because it's just a data feed that's being pulled in and displayed for us on a set. This is not a sense and avoid system. This is not a I can go anywhere kind of system, but this does help us get situation awareness for where the rest of our aircraft are. We can do some significant deconfliction between ourselves as we use this system to manufacture our mission set and our mission process. We are trying to take some of this information and port it eventually, but that's a process that we're working on, and it is not a sense and avoid system quite yet. So that's really what we're doing. I look forward to taking your questions. Flying UAs is a very exciting career field, quite frankly. I've done it for about 7 years, and there have been days where I felt like I was in the battle, just looking through the screen and talking to the folks on the radio. We have the same capabilities as I had in a manned platform, and some of them go even further than that. And I look forward to taking questions. Thank you.
Well, thanks, Colonel King. More they're the same, the more they're different. I mean, they're different and they're the same. There's interesting similarities there. Next is Captain Chernoff will talk about training, certification, and a little bit about sense and avoid on the technical aspects of UAS. So with that, Captain Chernoff.
Thank you, Bill. Thank you, Colonel King. I learned something new today. He follows the green line. The airplane I fly follow the magenta line. Anyway, good afternoon, everybody. Thank you for coming. Whether unmanned aircraft are accommodated or fully integrated into the NAS, the responsibility for safety remains the same, even though the tasks and details of operations are different. The news is full of stories about drones. You hear about it on TV, you see it in the newspapers, magazines, internet, and you hear terms like unmanned aerial vehicle, remotely piloted aircraft, predator drone, and the like. Much of the news touts the virtues and victories in faraway war zones, but the reports also suggest that thousands will be sharing the skies with the airliners sometime soon. The public and media mainly are concerned about privacy, potential use by terrorists, and taxpayer cost. Pilots, while also concerned about terrorists and security from hostile takeover, also express concern about jobs. While new jobs and new careers will likely come along with unmanned civil aviation, airline safety is as great as it is because of the people and human factors engineered into airline flying that will not be replaced by robots or remote cockpits. The main concerns of pilots are safety, and they fall into 4 main areas. Unmanned aircraft must comply with the rules of the air. In order to have equal access to airports and airspace, there must be a pilot in command who has the authority and responsibility just as any other PIC does. That pilot must be accountable to have the aircraft comply with instrument flight rules or visual flight rules. While many of the uses of unmanned aircraft are atypical, control of the flight path and altitude are essential. The skies are plenty crowded, and there must be a means to fly the correct altitude, determine legal visibility, maintain required cloud clearance, and required ground track. This is not a simple matter, and the systems that support this are far more complex than in typical light aircraft. Think about the altimeter installation in your aircraft and then consider remoting it to another location. An unmanned aircraft may be constrained to certain airspace boundaries or classes. The details of how this is accomplished can be quite complex. An unmanned aircraft must comply with ATC clearances and instructions and in a timely manner. How this is accomplished by remote control might be quite different than in your cockpit, but in all cases, there is some sort of auto-flight input. Communications are likewise complex, as they might need to be relayed from the location where the aircraft is actually flying to the pilot in some detached control station. Remote pilot training and certification needs to be developed. The ratings, limitations, and endorsements for the UAS pilot certificate will address the unique aspects compared with other pilot certificates. While most remote pilots today have come with a traditional flying background, many of the skills and cues learned must be unlearned to fly from a stationary cockpit. The texts, guides, maneuvers that have long been used to train pilots were designed for the training aircraft in situations of the day. The systems of even the most basic remotely controlled aircraft are vastly different than typical trainers, as are the skills that must be learned and mastered. But unlike sport or recreational flyers, unmanned aviation is in furtherance of a business or commercial activity, and thus all training must focus on professional standards and skills. The next generation of remote pilots will likely gain their training and skills from the start with these kind of systems. The necessary training hours and maneuvers need to be established and validated. With the exception of simple RC-like visual control, all remote flying involves instrumentation, advanced navigation, and autopilots. Pilot certification will need to include the competency of an instrument rating. When I was learning to fly, we started with simple systems and instruments and progressed to more advanced aircraft. Training was based on this typical progression. Today, both private aircraft and airliners are much more advanced. In unmanned aviation, a new pilot might start out with advanced systems and displays, and the training and qualification must take that into account. Regardless of the level of sophistication and automation, unmanned aircraft do use advanced instrumentation, navigation, and controls. They are not amateur sport planes and not a toy for the novice. Neither of these aircraft which fly in our airspace today have civil certification. While they are built to high standards, they were not ordered, designed, tested, or certified to meet any civil airworthiness standards, nor will they be. Many popular airliners today use advanced fly-by-wire technology. But even the simplest RC model plane is both fly-by-wire and remote controlled. Although these two aircraft are similar in size, weight, and performance, the passenger plane meets civil certification regulations and uses parts and avionics that meet TSOs. All controls involve cables or other connections contained within the aircraft. Even a simple comm radio or transponder in a UAS must be linked to a separate cockpit. This makes it neither simple nor cheap. Approved flight manuals and procedures are part of the civil certification process. Some think it's a shortcut to modify a certified civil aircraft, such as a Cessna Caravan, to be a remotely piloted aircraft or an optionally piloted aircraft. But the details of every normal, abnormal, and emergency procedure for a certified civil aircraft assumes that there's a pilot behind the windscreen. And all of those procedures would have to be redesigned to consider remote operation. Having a remote cockpit increases rather than decreases complexity. In order to share the airspace and surface of airports, unmanned aircraft must maintain safe separation from other traffic. While ATC may shoulder some of this responsibility in some airspace or under instrument flight rules, pilots routinely do this on the ground or when ATC says maintain visual separation. And collision avoidance is the responsibility of all pilots all of the time. This technical solution, or the technical solution to do both of these tasks, has yet to be accomplished for unmanned aviation. However it is done, it must provide unmanned aircraft safety 100% of the time. Whatever equipment is on board the unmanned aircraft, it must also be compatible with those systems used on other aircraft and ATC to manage separation and provide collision avoidance. In other words, unmanned aircraft must be seen by others so that they may be avoided. Encoding transponders, ADS-B, and even lights are technologies, when installed on unmanned aircraft, provide for this. TCAS is clearly not going to fill the bill aboard an unmanned aircraft or linked to a remote pilot. Time delays, response times, aircraft performance, or even the possibility of link interruption preclude this as a solution. For a true sense and avoid system, the onboard sensors must detect all intruders, not just those with Mode C transponders. Self-separation or collision avoidance maneuvers might involve lateral rather than vertical solutions and must not be subject to control link availability or response delay via the remote control. You hear a lot these days about ground-based sense and avoid as an alternative to an airborne system. While it sounds sexy and attractive, it still involves using sometimes fickle control links and relay of a human response. What it really is a dedicated, high-resolution surveillance radar system. It can provide simple intruder alerts, allowing limited UAS flight operations in a particular area without creating special activity airspace, or it can provide some level of conflict resolution for the remote pilot. While it might be useful in testing and validating a true airborne collision avoidance system, it can never be a substitute for one. ALPA and its affiliates continue to advocate worldwide that equal access to the NAS by unmanned aircraft requires the responsibility of an appropriately trained and qualified professional remote pilot. There are many details yet to be developed and resolved during certification of the aircraft, control stations, links, remote pilots, and commercial operators. Current off-the-shelf hardware and software were not designed or certified for use in these systems, and there are many additional details to adapt them. Some new concepts, such as optionally piloted aircraft or ground-based sense and avoid, might be useful to develop and validate new equipment, but they are not a substitute or a shortcut solution. The amount of time already elapsed in bringing forth civil certified routine operations has frustrated many proponents and advocates and has resulted in lobbying and political pressure. Committee deadlines and legislative mandates have been the obvious response. But there can be no shortcut to safety, and we have a responsibility to our pilot membership and to the public we serve to hold fast to the highest standards of safety and to get the details right. Everything matters. Thank you very much for your attention. Bill?
Well, thank you, Ellis. At this point in time, take some questions. So if you would make your way to the floor mic, state your name and organization, and we'll get started.
Thank you very much, Bill. My name is Nico Vorbach. I'm from the European Cockpit Association, but doing aviation security since 1999. And what I miss a bit in all of the presentations, who are rather good, thank you very much for all the information you give us, but I miss a bit the security part of it. We can talk about cyber threat. I think everybody knows that. You can hack in those systems. But what I found more interesting is the taking over of a control center. I know the military control centers are very well protected and mostly in a bunker. But when we introduce civil unmanned air systems, as soon as this is taken over, it can fly everywhere. And it is very hard to get into a cockpit of a flying aircraft, but we are now creating an area where it is easier to take over than a cockpit. If it's just a trailer where the command control is, or a normal building where the command control is, then it might get a bit scary, especially if I see the command and control center of the military where you can see all the other aircraft flying around. Are we not creating a hazard that we're just trying to get out of the civil aviation by locking the cockpit door, putting air marshals in, and now we get systems that are more easily taken over.
Is a question to ask? Maybe I can move that and ask maybe Rick if there's something regarding security in a plan for a security element in the comprehensive plan that the FAA is going to develop.
Well, certainly there really is two aspects involved. One, as you point out very adroitly, is the actual security of the control station from which the aircraft is being manipulated. And then the second aspect of that is the security of the control link, that if perhaps someone wouldn't even need to get to the control station itself by spoofing using electronic signals to take control of the aircraft. So that is the second facet of that. So both of these are very important aspects that we're looking into. We have a number of different entities and efforts working on this. We have the RTCA Special Committee 203, one of the 4 subgroups there is working on the command and control aspects with the communications. Also, there's a very large, NASA has funding for $150 million for UAS research over the next 5 years, and one of the 4 aspects that they're looking at is the security of the communications and trying to develop the standards and equipment that a spoofer could not take control of the aircraft. And we're working these in a wide variety of international organizations as well. A lot of cooperation up in the International Civil Avionics, or the ICAO organization up in Montreal, the EuroCai, the European counterpart to the RTCA. So for the security of the links, we've got a lot of work going on there, and certainly the security of the actual control station itself is also looms very large, and 2 very good concerns that we're very much interested in trying to make sure that either intentionally or unintentionally that we do not have problems in that regard.
Can I ask you the question, do you think that will be solved within the 5 years that we are looking into implementing it into the NAS?
I think that, we've got an awful lot of very large brains working on this, both not just within the agency, but across industry and the other our governmental partners, and I think the synergy from all of these entities we will find solutions and a path forward.
Thank you.
I think just to add on to that, Nico, too, obviously the security and the cyber threat all factor into the safety aspect. And it was mentioned that it's the safe integration of these vehicles into the airspace. So I think after the UT tests, everybody's very well focused on that issue. So it puts a laser light on the problem. Thank you.
How you doing? Matthew Kane with Air Train Airways. My question really was with for the panel. When I get in an airplane, I know I'm in an airplane, I know I'm in a jet. Do you guys have any morale hazards associated with, hey, it's on fire, it's not my problem, I'm going to go back and drink a cup of coffee or something? Like, do you have any, has that been an issue with the airplanes that have been previous to this?
Any,
I can take that for you.
Sure.
Actually, quite the opposite to that. When I was an instructor pilot, one of the challenges we went through as we tried to reinvent our training program was to ensure we kept the responsibility factor involved in the training program. There was a lot of folks that wanted to take out some basic aviation concepts and thoughts. You can't do stalls and falls on these aircraft because A, they're protected from doing that electronically, and you don't have the cues that you would normally have to do that, so that would be a bad thing. But there are some other basic aviation stuff that we teach people. The experience from an emergency, we take them through a simulator and we step it up and we step it up and we step it up as we're going through the training to put that same style of pressure on folks to the point where it's really just like you're sitting in it. I've actually been around a guy that just lost an airplane through no fault of his own, and he was devastated for about 3 days. We had to sit him down and because he was in the same mindset of I just lost an airplane, whether I was sitting in it and jumped out of it or if it just didn't come back today. one of the most harrowing experiences I've ever had is trying to land an aircraft. We had one that came back with some malfunctions. And I was literally walking out of the ground control with my hand shaking, and I'd never had that experience even trying to land a T-38 no flap with a student with a melon this big in the front, and you can't see outside other than over here. It's very much a personal experience trying to fly the aircraft. And the more and more you fly it, and the more and more you get involved with what it does and what it can accomplish, it becomes every bit as personal as flying an unmanned aircraft.
Thank you, Colonel King. It looks like we're going to be out of time, so I want to thank our panelists for taking the time to make these presentations, and you can expect more work in the future, so thanks very much.